It's good to be here. I've never made a presentation here, but we've worked with you over a number of years on several different projects. I assume that I'll just move through the slides, but this first one kind of indicates that we really like to work with communities. And when we talk about green infrastructure, or in this case, we would call this a bioswale in a parking lot or a rain garden. Very often, it's a crowd of kids on a school day or on a weekend planting like crazy for a few hours, and then helping to maintain that for as long as they're in school. The Center for Neighborhood Technology has been around about 32 years now, and we are sort of a think and do tank. We like to do research on urban problems, particularly things like transportation, land use, affordability of housing and transportation, and our own natural resource group focuses primarily on green infrastructure, promoting it, researching it, and hopefully eliminating barriers to establishment of distributed stormwater management. I'll mention our agenda later. This is our garden next to our building, which is includes, to the right there along the building is a rain garden that takes water off of the roof. In the back, we now have a 330-gallon super barrel that can handle the water off the roof as well, but this was taken a number of years ago. We developed tools. The Water from Trouble to Treasure there, unfortunately, we're out of all but a very few copies. But it was meant to essentially encourage people to do things in their own neighborhoods, in their own yards, in their own villages, probably even as other kinds of planning is going on, so that take personal initiative as you think about your own lawn, while the the village, the watershed group is thinking longer range. The thing to the right, we've spent a great deal of time with the Water Reclamation District of Greater Chicago, encouraging them to look at green infrastructure as part of the solution to stormwater management for the Chicago region. We have an excellent GIS department that has made great strides in a number of research projects, bringing them to the public in terms of GIS mapping. And one of the things we do is work with Chicago Wilderness and other entities on mapping the natural resources of the region, making the maps interactive so that they are available online for anyone that wants to use them. We have developed 3 different versions of an online calculator at greenvalues.cnt.org that are meant for lay people, engineers, developers, planning departments, to take a preliminary look at a piece of property, whether it's a single site or whether it's a neighborhood or even a small watershed, and take a look at what the impacts, the benefits, the costs, and the hydrologic changes that can be made by employing green infrastructure, so that you can choose rain gardens from the roof, you can choose porous pavement, additional trees, swales instead of storm sewers, and green roofs. Any combination of those things you can plug in using a template developed by you about your site, and come up with some preliminary numbers in terms of how much money you can save, what kind of stormwater flow reduction you can get, and what kind of additional benefits you can get. So encourage you just to go online and use that get a little practice in it, and then hopefully you'll find it a very useful tool. We are currently working with the Sustainable Technology Center on some monitoring projects that I'll talk about, and our partner in that is Hay & Associates, which is an engineering firm up in Chicago that was founded in 1976, you can see here. But they are an excellent firm and have done a lot of monitoring over the years for the city of Chicago and other entities, and they are our technical consultants. The projects that we are working with the Sustainable Technology Center began in 2007, where with two different projects. We had a project funded by the U.S. EPA in the city of Chicago to look at, well, what it was is we developed 4 green infrastructure features and then monitored those. And what we did was we went to the city of Chicago and said, where are the problems in terms of stormwater? And we got a map that showed everywhere. There's really no blank spaces on that map. So the city suggested that we look at churches as community places that have campuses, the places that sort of help form a public opinion, and we ended up working at 2 different churches in the Chicago area. One is way on the far north side, called St. Margaret Mary, and I'll refer to that name. And the other is on the far south side at Our Lady Gate of Heaven. In addition, about that same time, we got some funding from the Illinois EPA, and there we worked outside the city, established 2 rain gardens in the village of Bellwood and a vegetative swale in Lake County. So we'll talk about those projects. And then we're continuing some of those projects under the funding now with the university here, or this technology center. In addition, we and primarily Hay & Associates were monitoring other facilities throughout Chicago. We do a lot of rain garden demonstrations. We've been involved in overall some 30 different facilities in various ways. We do a lot of policy analysis. Steve here and other people on our team spend a lot of time with the U.S. EPA, with the state EPA and the legislators, helping to develop new policy dealing with green infrastructure. This is, well, the Calumet Bioswale, which is at Our Lady Gate of Heaven Church. We located that because this parking lot that you see fills with water fairly frequently. And before the bioswale went in there, it was by tonight or today would have been full of water, I'm sure, and sit for a week or 2. We put in this bioswale. It's 10 feet wide and 66 feet long. We didn't put it at the bottom of at the lowest point in the parking lot because the lot was just too big for our budget to build a facility that'll handle. So this accepts water from about 12,400 square feet of the parking lot, which generally from the right side of the picture flows into the swale. The left side has another drain, but the problem with that drain is that about 6 months or so ago it was destroyed as they put in a new street light in the street. So we're still trying to get that fixed, but in the meantime, the water backs up in the rest of the parking lot, and after about a foot about a half inch of rain, it fills up the lot and kind of backflows into our facility. But we still get good data as the facility draws down. So we find that the infiltration rate that's a parking. Even now, you can see occasionally the water fills up, and now it takes a matter of a couple of days rather than a couple of weeks like it used to, because the bioswale works. We find an infiltration rates of from 0.2 to 0.8 inches per hour in the underlying soils, which is the governing soil layer there. Again, it works for about the first ½ inch of rain, and after that, you tend to get the back up. But we're trying to get that repaired. I hope you can see this reasonably well from the back. Steve wanted to insist that I make everything darker, and I didn't know how yesterday. We have 3 well points in the bioswale. The first measures the this is the ground level. So this one of the gauges would measure these probably blue color. The red here is a well point a couple feet below grade that measures the water level in a stone layer underneath the soil, and then we have a deeper well point, just a few feet deep, that measures the water level in the deeper layer. We have a rain gauge on the roof of the church, and measures 5-minute intervals. We download it about once a month, as well as the meters in the bioswale. And then the slopes of these lines are most important in terms of determining just what happens with that saturated water layer in the bioswale. I didn't mention, we like to put native plants in our facilities whenever we can, which is almost all the time. And they flourish in this kind of inundation several times a year. And one of the reasons we are monitoring is to find how the permeability of the facility changes over time as the plants mature and change. In plotting the runoff, the inches of runoff here versus what's captured in the BMP, in the bioswale, we have these triangles are when there is no overflow from the facility. The squares measure events where there is overflow, and you can see that it's roughly capturing all of the storm up to at least a ½ inch, and then there's sometimes we get overflow. We do have reports. Actually, the first 2 years we did this, we have a report that was produced for the US EPA, and that's available. We're now reporting to Nancy in the Sustainable Technology Center. Yes?
But you do have an overflow event there with less than a quarter of an inch, so that's due to the intensity, I would guess?
Yeah, well, probably, although there's several of them in that range. And what it may be is that the intensity, but see, we don't know whether this is overflowing into the rest of the parking lot or the rest of the parking lot is overflowing into this. And we're going to put a meter in the sewer that goes from the malfunctioning sewer to make sure that we know whether it's going back or forward. But I think there's probably 3 times the area flowing into the sewer is flowing into the bioswale, so it backs up pretty quickly when it's plugged. We also, in addition to what we were funded to do, we were able to get Ozinga Construction to donate some porous pavement patches. in a parking lot at St. Margaret Mary Churches on the north side. And that was done in 2008. We dug the hole and they donated the concrete. I actually have a sample of that. We took a boring recently. We took 4 of them, and I'm going to leave one here with Nancy if you want. This actually is plugged. I'll show you that we cleaned it, but you can't really see the innards there in terms of what's plugged. But pardon me? Well, it would work, although probably it would work better if you turn it upside down and flush the stuff out, but it will run right through when it's reasonably clean. So it's been monitored last year and now again. So we had a 8,700 square foot parking lot. We simply took, there were 2 drains in the parking lot. We cut out a 15 by 15 foot hole in the original pavement and filled it with this. So we have about 450 square feet of porous pavement in this 8,700 square foot parking lot. So it's roughly 18 times the size of the porous pavement. And initially we didn't have funding to monitor it, but when we finally did monitor it last fall, actually it was in June or July, it only had a rate of 1 to 1.5, 1.08 to 1.31 inches per hour. And we were a little disturbed because it was reasonably new. So then I'll show you a slide later, but after it was washed with just a simple power washer, the capacity, it went up to 32 to 88 inches per hour in several different locations within the patch. And that was in I think November last year. And this spring, just a couple of weeks ago, it was in the range of 6 to 63 inches per hour with an average of 38. So we lost maybe a third of its capacity over the past winter. But we found last year that going from practically zero infiltration to way up into the 57 inches an hour range could be accomplished with a very simple washing technique. And they know there's a number of sort of vacuum systems. There's the typical street sweeper with water, and even this hand device worked very well in cleaning them. So what we're going to be doing this year is alternatively letting it sit, measuring, and then cleaning and measuring again for the rest of this year. In the village of Bellwood, we were looking for a place where we could build a rain garden with turf grass in it, and another one that's very similar with native plants, which we did. The first one here is the turf grass, and then back here is a very similar one with native plants. And these take water off of a roof, and we built them up because in order to protect them, we had to have them within the fence of this water department at Bellwood. And in order to squeeze them in there, they're in a sort of a swale that takes water from one end of the building to the other. So we were concerned that we would swamp the garden, so we built them up. And there we measured in 2008. And what we found is that the performance of these things is such that really one well in each garden is not sufficient. And we also we were measuring the rainfall in 5-minute intervals. We finally moved that to 1 minute interval, and then we got similar kinds of charts. This is June of 2008. They both are June 2008. This is the native garden. This is the turf rain garden. It's a little confusing because this one is for the entire month. This one is only for the first 17 days. So the first 17 days are about here, and they do respond to the same rainfall. What we found was not what we wanted to hear, but that the turf garden was vastly superior to the native plants in terms of the permeability or of infiltration. And so we've continued to work, and what we found if doing some testing with infiltrometer, that the turf grass is 91 inches an hour, the native plants are 3 inches an hour. Now there's some explanations for that. For one thing, the turf grass was replaced onto the thing, so that it was essentially pieces of grass that were stomped back in place, and which was a much rougher surface than the native plants, which were planted on essentially mulch and soil, and they were immature, so that the spreading of the turf grass kind of was immediately caught, whereas the other one it kind of ran toward the edge. But the other thing, the design had a flaw because despite aligning, the edges of it leaked. So what we're now doing is we are doing most of our testing with the infiltrometers, which we'll talk about, we think is really the best way to go anyway. In addition, during 2008, we located a swale in Lake County in a front yard that's about 250 feet long. This is a picture from the road toward the fence in the back is where it leaves that property. And you can see the turbidity of the water. And by the way, we got a lot of help on designing these things in the initial work from the Illinois State Water Survey. We thought they would be doing the monitoring, but the sort of intensity of having to do it following a storm, they've got a limited staff, and it would have been impossible to do it. So we hired Hay. But So what we constructed here, this is before the construction, we constructed a measuring device here, and then one down there, and have measured the flows in and out of that swale for during all of 2009. When we got our funding from the ISTEC, Illinois State Sustainable Technology Center, we proposed that we would find another swale and do a similar kind of thing. We found a couple of things. One is that there are very few, we could not find anything comparable at all. We also found that there really wasn't much interest among our sort of constituents, the regulators and the engineers and things, to do these kind of things. So what we proposed with this center here is we did not build another one of these. We have another program instead. The other problem with this one is the water was very turbid when we built this thing. But by the time we put the monitors in, two things had happened. One is that the watershed, which is about 100 acres, had shut down development because of the economy, so that we're no longer getting fresh, good, muddy runoff. actually, there was a really good horse farm that had a nice manure pile that we were looking forward to having a lot of nutrients. That shut down, and there was a pond put right upstream. So what happened is when we finally got this going, is that we had cleaner water. The water going in was as clean as we could possibly expect going out. So the water quality data was less than helpful, but we got some very good quantity data. So in this one, we based on 8 storms, we got this dark line here is here's the rainfall up to 2.5 inches, and the volume in cubic feet that flowed through these swales during that storm, and then the volume lost is this line down here, and the diamonds here. And what we found is that roughly, so for a given rainstorm, the percent of the total runoff that the percent of the total annual runoff at, for instance, under a 2-inch storms under 2 inches would be here, and the percent of that was removed in the swale is down here. So that roughly some 20% of the stormwater that enters that swale can be expected to infiltrate over a typical year. So in some ways it was a very effective runoff reduction method. So what we propose to do this year, and what we're doing now, is to conduct an inventory of all the green infrastructure kinds of facilities we can locate in the Chicago region, roughly the 6 counties. And we are documenting them. And then we will run tests on some of them and report back to people who are interested. What we found is when you've got just a few sites and you're dependent on the weather conditions, you end up with very little data over a period of time. And what we want to do is do a large number of sites and increase the level of data on those that are the most interesting, but be able to get a scan of a great number of sites. So we've located about 82, 85, I think, measures, as it says here. Well, maybe it was back to the other one. Okay. What we're going to do is visually look at about 70 sites using procedures that are developed at the University of Minnesota, and then do capacity testing using infiltrometers at about a dozen of those sites, and then we will fill the sites where about 4 of them where it's appropriate, where you can fill them, and just measure how the water infiltrates over time. So now we've located about 82, well, now it's 85 facilities. 36 of them are rain gardens. There's some permeable pavement and bioswales. I expect that we will, I'm a little disappointed that we haven't found more by now, but a number of our best informants haven't yet inputted to the online survey. But we expect to have at least 200 facilities, and we will select about 70 for doing the work. And so initially, there's a visual assessment where we go out and look at the condition of the site and the vegetation and the inlet and outlet to make sure and look for sedimentation problems. and then select some for the infiltration and then drawdown. This is, we will be looking at porous pavement. This is our guy from Ozinga who came out and he says, don't worry about plugged pavement, and within an hour with those two sites, they were in good shape again. And for a small site like that, this kind of a technique would work fine. For larger sites, obviously, you need a mechanical equipment, but it does recover. Now, we've got a number of things that we're moving toward. I'll let Steve do some talking about some of them, and then we'll answer a lot of questions, hopefully. Not this.
Well, thanks. So, as Bill said, what we've been talking about here is a lot of data and monitoring from primarily individual sites, individual practices in one place. And if any of you have followed what's going on in terms of the application and development and pursuit of green infrastructure, what we want to see in a more general sense is that this is a community scale practice. As Bill said at the beginning, the Center for Neighborhood Technology, we look for sustainability practices that work at neighborhood and community scale. So it's not a question just of saying, well, what can you do with an individual residence, or what can you do with a commercial building or something else, but how does the actual neighborhood and the infrastructure of a part of a city or an entire community or a region perform, and how can we take the individual practices like this and build them up to more of a regional scale local infrastructure. Or even when you look at stormwater, it tends to be dividing urban areas into sewer sheds. So how do you get from a site-based practice, the performance level of a set of individual practices, up to a cumulative regional infrastructure performance? We want less combined sewer overflows. We want less pollutants reaching streams. We want less basement flooding in communities. These sort of disturbing factors that we're trying to manage when we're talking about stormwater management or rainwater management, as we begin to think about rain as a resource here. So it's how do we bridge this gap from individual scale performance to community scale, where the neighborhood is the technology, we're getting up in scale. And what we're proposing for this, we've developed the idea of a permeability index, so a regional scale index that measures the performance of a given area on a cumulative basis. The idea being that oftentimes when you look at rainwater and runoff, people look at the negative force of impermeable area. So the first thing is to say, well, what's the impermeable area? And so for a place like Chicago, for example, it's 25 or 30% or more of an area. It may be up to 60 or 80% in a neighborhood that is impermeable surface. That's the root of the problem. But the idea is with some of these green infrastructure practices, as Bill mentioned, for dealing with a percentage of the physical surface of an area, you can absorb a much higher percentage of the runoff. So you can turn that into the problem into a solution and look at the cumulative performance of what we're calling this permeability index, moving from the site-based to the community scale impact. And then be able to do scenario planning and saying, well, if I want to reduce the cumulative runoff for this sewer shed or this neighborhood or this block from what it is now into a higher performing area, how much green infrastructure would I need to scatter across the landscape or strategically locate in areas where some of the water can be collected to make that performance benchmark and essentially move up the permeability index scale down the level of runoff and improving sewer or other infrastructure performance along the way. And then looking at the life cycle cost of these scenarios, because the construction cost, the initial construction cost, is just one piece of infrastructure planning. Infrastructure systems, bonding, financing, planning, and investment at civic levels, at community levels, tends to be on a life cycle scale. So our calculator and the estimates we want to do with this is to look at the long term, look at a 30-year or longer life cycle, which is comparable to other infrastructure investments, and say, how are you doing on a life cycle basis? Because as you know, our basic philosophy is the sustainable has to be attainable. You have to deal with cost effectiveness. You have to be able to identify the times and the ways in which green infrastructure and other sustainability practices actually save money while improving performance over time. And then improving just the accountability of performance over time, being able to check back and say, well, if our performance target was to reduce runoff by 10%, 20%, 80%, are we making those benchmarks? Are we affecting the community and the infrastructure on a collective basis that we want to, where only that which can be counted upon, and when you get into actual regulatory responsibility. Cities and communities have legal responsibility under the Clean Water Act to manage and reduce and control runoff and eliminate the negative impacts on water quality. So the idea is to increase accountability through this and the degree to which green infrastructure can be a part of the solution. Finally, the idea then is to give yourself a better ability to capture the capacity, the latent capacity of the urban landscape to utilize green infrastructure. That's what we're trying to do with this permeability index. And it would have three components, in some ways analogous to the research that this project is helping us to identify. We need a registry of existing features and a system by which we can collect where these things are being built over time. So we need to know what the baseline is, where existing impermeable surface, where existing permeable surfaces are, where the constructed green infrastructure practices are, and where they get built, so you can track how they affect neighborhood performance. This is an example from the city of Milwaukee and their best management practice tracking in terms of rain barrels and other practices around the city of Milwaukee. If you have this baseline, you can say, all right, how much water, and we have this performance data from the tracking that we're doing in this and other projects, how much should these features on a collective basis distributed through their sewer sheds and their watersheds, how much are they affecting performance in the infrastructure, how much could they affect, how many more do we need of rain gardens or vegetated swales or water harvesting facilities or green roofs, any of these practices, green streets, green parking lots, when you get to cumulative treatment trains, how many of those do you need to meet that performance target? And then being able to describe, as Bill said in the registry or in the what we're doing now for this the survey, what the feature or what the design components, the depth, the underlying aggregate, some of the design components that actually affect performance of those things, keeping them listed in a registry. So again, we know what these features are supposed to do on a cumulative basis, and we can count what the performance should do over time. So that's an example of a project how we want to take this into the next step from doing monitoring data into an actual neighborhood performance monitoring tool. Another level of that is what we're calling least cost or sustainable Great Lakes water planning. The idea here is that, again, at a community scale, at a utility scale, we make plans to invest our infrastructure money on a long term, and we try to do it based on performance and cost effectiveness. But if you cannot count the benefits of conservation practices, including, for example, the energy savings from not using pumped water, the cooling effect of having trees planted in urban areas and reducing building energy, the stormwater absorption some of these things do. So we're looking at trying to take this to a utility scale and look at it in a planning framework where you look at what's commonly called integrated resource planning on the water supply side or in energy and transportation systems, to do this integrated resource planning where conservation-based practices like green infrastructure would have a equal or preferable status in terms of selecting options and selecting scenarios of how a community might do its infrastructure planning in the long term, taking advantage of and accounting for the conservation benefits of green infrastructure. This is a new project. We're in the beginning, the late in the first year of a 2-year project. We're going to have a workshop on this fairly soon in late April in Chicago, and there'll be more information about this project as well on our website. And then we're also trying to figure out ways that some of these performance data can be integrated with policy making and policy decisions. This chart is preliminary information that we've been gathering for a State of Illinois study that we were working on with the University of Illinois Chicago, Illinois Sea Grant, the Chicago Metropolitan Agency for Planning, and which was a product of state legislation. The Public Act 960026 last year said IEPA shall study standards and rules and regulations through which green infrastructure practices can be brought into the state policy for managing rainwater and stormwater. So we're working with these other partners on doing a study of what the effectiveness and the cost effectiveness of green infrastructure practices can be, what policies may exist either in other states, other parts of Illinois, elsewhere in the country that could become part of state policy to prioritize cost-effective practices, these practices that are ecologically and socially effective. And these are just some examples where the cost scale in terms of construction costs per square foot of of building a given green infrastructure feature is one thing, but what we really want to do is look at the performance, what you're delivering over time, the cost per cubic foot of water removed. And this is relevant at a national level as well. If you're following this with the U.S. EPA, EPA has announced its intention of developing new stormwater regulations, new stormwater rule over the next 2 to 3 years. And based on existing research, particularly the Natural Research Council report from 2008, looking at the idea that instead of managing for control or sequestration of individual pollutants, it may be much more effective and more efficient to manage for the volume of water. Because if you can manage, if you can slow down and reduce the amount of water that's running off into streams and lakes and water bodies, you're getting a proportional reduction in the amount of pollutants reaching those water bodies. So the policies are moving toward this volume-based hydrology, the need to know volume-based performance and the cost per volume of service delivered through whether you're using conventional infrastructure and treatment or green infrastructure and treatment. So we're trying to get to some of those factors that can then feed into national policy, shape the way that national policy may get written. And the EPA has said one of the most important things they need from Illinois or anywhere else in the country is what the performance data look like so far. The kinds of things that this study is trying to produce are necessary inputs to saying, well, how far can a state policy or a national policy or even a local or regional ordinance say, utilize green infrastructure practices to do what they do effectively, to what extent? So the monitoring data are directly related back to these policy questions of how much we could and should invest in green infrastructure practices in conjunction with or in substitution for conventional infrastructure investments. And then we finally come back to the idea that green infrastructure being a distributed practice, it's a lot of little things that have a big cumulative impact. It's not essentially, we're kind of changing the way that we think about how infrastructure needs to be developed and designed, going from centralized treatment and conveyance to distributed natural-based systems across the landscape. And this was a project, one of our first demonstrations at a school called the Al Raby School for Community and Environment on the west side of Chicago. We found that by removing 1,500 square feet of pavement, of sidewalk on either side of the school entrance, we were able to eliminate some basement flooding problems they had, educate the students, and when one of our colleagues who was helping develop this school encouraged us to name the garden after Nobel Prize winner Wangari Maathai, we found out she was coming to town and we invited her for the dedication. Well, there we go. So if you're interested in meeting Nobel Prize winners, start some more green infrastructure, right? She came along and she gave us what's been one of our mottos ever since, saying that this is the kind of project that needs to be repeated 1 billion times around the world. So with that as our objective, we're going to need all of your help to achieve Wangari's noble goal. And with that, we'll thank you and be happy to answer questions about our monitoring project.
Yes, maybe it's a good opportunity for ISTC and CNT to create a collaboration with a group right here in Champaign that is leading the charge on working with city staff, city council, and now landscape architecture class, and developing green solutions for stormwater management for John Street watershed. And our leader of this group, and we're well into this process, and it's going to become a model for the rest of the watersheds within the community. It's a wonderful ongoing project that seems to me pulls in very nicely with everything that you all are thinking about doing and monitoring. And then my question is, in all of this research, do you have any, or a collection of model ordinances that we can begin to capture to start the city council to consider ordinances that will work toward more permeable surfaces and some of these issues of runoff when permeable surfaces get covered by buildings or concrete or things like that, because this isn't happening here yet, but we're moving toward that, and model ordinances would be terrific to get a hold of.
You can answer about the ordinances, I'll talk about the neighborhoods.
Okay.
Sure. In terms of the question being, are there examples of model ordinances? There are model ordinances. I know that what was the Northeast Illinois Planning Commission, NIPSI, had a model ordinance. There's a really excellent resource for reviewing your local codes and ordinance that's produced by American Rivers, the National Conservation Group, and I don't remember the name of it, but if you look in their clean water programs, then the interesting thing is that what they found, they did this in conjunction with Wisconsin Environmental Advocates, that it's not just the stormwater regulations or the stormwater ordinance that you need to look at. Some of the most effective things you can do are looking at parking ordinances and looking at street widths, going from things like it's common to have maximum required or required minimum parking ordinances. Instead, you can turn that upside down and say have a minimum parking requirement, and to limit the amount of parking that needs to be built with any given development. Some smart things about retrofitting that you can do. So there are good examples of that. Also, I think some of the work that we're doing in terms of reviewing policy options for the state may become relevant. That report should be done by about June or July. So the state policy review will talk about state and regional policies around the region and which ones can lead you down the path toward better use of green infrastructure. And then I think the Hickory Creek project, we're also going to do some policy review looking at what the ordinances are among 6 communities, or is it 7 now, 7 communities around the Hickory Creek drainage, and how some of their ordinances may be consolidated and made more consistent in support of that kind of objective. So I think we may have some good examples of that for you over the next year. I'd encourage you to stay in touch about that, and then Bill can talk about.
One more question
Yes.
on that. Are you looking at any relationship to the outlying drainage districts? Because if you look at the map of the drainage districts within Champaign County, it's frightening how many are there, but they all feed into the problems of flooding within these communities. I mean, Urbana is having the same problem. I happen to be involved in Champaign, but how one can work with the drainage districts, which is a complex issue just in and of itself, but it just comes all into play. We can't silo this out.
Drainage districts are tough. Obviously their priority is usually agricultural. And we have some in Illinois, but that's not what we usually run into. What I'd like to do with you or you, Nancy, is let's just keep in touch with by phone or something. And we like to work with community groups that are doing things. This is a little bit of a trek for to run back and forth too much. Yeah, I know you are, but I think we can be helpful.
The CMT has done a handful of other projects in Champaign and Urbana so far, and as Nancy said, we are trying to. We often start in Chicago because that's where we're based, but we recognize that if we find something useful, we want to share it, replicate it, and you can probably help us learn to solve some problems we may not have encountered in our own worlds up there. But it's worth maybe another good example.
Thank you.
Questions? Sure.
The pervious concrete, they put a pathway in one of our local parks here, Carl. And I'm curious, if this gets clogged up in the winter and there's water in there and it freezes, I can't think of a better way to crack concrete. What is the experience that you've had with freezing water in there?
Well, we've only had a couple of years' experience. We have no trouble, but we have confidence in some work that's been done by at least one of the contractors with the porous concrete. And what they find is first of all, because it's so porous. Now, when it's clogged, even then, we're still getting 3 inches an hour, or 1 to 3. But normally, if you keep it clean, you clean it in the fall. It is so porous that the water doesn't stay in there in bulk, and there is stone underneath it, at least 6 inches, and so you end up with a dry concrete instead of water-filled cracks.
And there's actually national research on this. The New Hampshire Stormwater Center and the Toronto Region Conservation, TRCA, Toronto Region Conservation Authority, have both done monitored studies and found that permeable pavement, well designed and well constructed, has less freeze thaw than conventional concrete. And again, as Bill said, it's because of the porosity and some of the conduction of heat that it freezes less on the surface, it melts faster. And so in side-by-side tests in Toronto, in New Hampshire, and elsewhere, the studies have found that in Chicago, there's some parking lots monitored in the city of Chicago now. The city and MWRD are also monitoring this. Because of that conduction of heat and the ability of the water to pass through, and there's expansion space in the voids that you can see in that sample that Bill brought. There should be 15 to 30% void space in here, so that frozen water has somewhere to go. It actually can improve the durability of the surface as long as it's managed properly otherwise. So that it should be, what we're seeing in the research, a solution to freeze-thaw problems in concrete. And the other thing that those same studies in Toronto and New Hampshire have indicated is that because there is less freezing and it thaws faster, you can use less salt, or in some cases eliminate salt, on permeable surfaces that you would otherwise have to spread to de-ice a conventional concrete surface, which becomes another element of efficiency both in cost and an ecological reduction of salt impact, which is a whole different problem.
But they're not used for roadway surfaces, though.
For parking lot surfaces, there are places that are trying it out. In roadway surfaces, the one that I know of is there's a elder housing development called Autumn Trails in Moline that used paver block systems, not concrete, but paver blocks for residential streets. So the paver block systems, from what we're told, are pretty bomb-proof. I mean, you can use it in almost, there are industrial shipping yards that are using permeable paver blocks for, industrial weight trucking yards and things like that. The permeable concrete may not be as durable as for roadway surfaces like that, or permeable asphalt has some other problems, but if you can work out the cost of paver block systems, that's something that people are using more commonly in roadways, or at least in the parking margins of a roadway. And I think the example that Bill showed is another good one, where in our experiment we didn't resurface the whole parking lot. It wasn't necessary. And what the city of Chicago has found in its Green Alley program, for example, is that instead of resurfacing an entire alley width side to side with permeable concrete or asphalt or paver blocks, you can take if it crowns to the middle, take the center strip and put permeable material in the center strip and drain it to the center strip. If it crowns to the edge, put the permeable material on the edge and leave the conventional surface in between, and then both reduce the cost but maintain the performance simply by using a portion of that surface. And if it's concrete or asphalt, the general conventional wisdom out there is that you don't want it in turning surfaces. So it may not be so good for the concrete or the asphalt. May spall off a little bit if you have parking lanes, for example, where people are turning their wheels without moving. That friction can give some problems to the top surface of some of these materials. But it's site-specific, and then there are places where, again, for I think in Louisville and other places where they're starting to use the paver blocks for parking zones. If you have a conventional street, and I think Chicago's doing this in some places too, a conventional street with permeable paving along the edge for parking, again, you can catch that runoff before it hits the gutters in the sewer system by only using a portion of the paved area where the material is appropriate, where its function is appropriate, and it's not going to get worn out too quickly. So part of it's design sense, part of it's material choice. So they can record.
Oh, I see. Hi. I coordinate the stormwater program at the university, so perhaps we could talk about maybe a collaboration. But the question I have for you is about your Village of Bellwood rain garden, turf grass, native plant tests that you did. I know the University of Wisconsin has done some similar tests as well. And with yours, did you give enough time for the native plants to really establish their root systems? It looks like your data collection was in May and October. I didn't catch when the beds were established.
Well, we're giving it time.
So it's still ongoing.
It was planted in mid-2007, and the last time we really did work out there was last fall. So it's had 2 seasons. Obviously, we want to monitor it now for another year. Hopefully they will be around for years and years and years because it is in a protected area. Let me mention one other thing that I forgot. We measured like 81 inches per hour in the turf grass, 3 inches per hour in the native. One of the things that the University of Minnesota is finding is in the same garden you can have 10 or even 100 times as much over here as you have over here. So you've really, one of the things we're going to be doing is selecting several places in gardens to do the infiltrometer tests because it just varies. Now I'm sure, we're confident that in this case the turf grass is working better, but we expect that the other will catch up. But we've got to do more than just 1 or 2 tests in each one, which is what we plan to do this year.
Why don't we thank our speakers for the day, and if there's any more questions we can continue, but if anyone needs to leave, it's exactly 1. So thank you very much.